On March 7, 2009, NASA launched the Kepler Space Telescope into orbit around the Sun. Outside the Earth's atmosphere, it would be free to peer deeply into a cross-section of our galaxy in search of new planets orbiting other stars. After 9 years in action covering 2 separate mission phases, designed as Kepler and K2, the Kepler Space Telescope finally ran out of fuel and was forced to cease operations in October 2018. But over the course of its lifespan, it discovered more than 2,600 new planets, at least a few of which may be capable of supporting life. In addition to the 2,681 objects already classified as exoplanets, planets outside the solar system, the US Space Agency listed another 2,899 candidates for planetary status that have yet to be verified, and a positive result is expected for most. As of 2015, the data from the initial Kepler mission, K2 data was not yet available, had confirmed the existence of 30 to 50 Earth-sized planets known to be orbiting inside their star's habitable zone, which means temperatures would allow for the existence of water on the surface. As NASA's first planet-hunting mission, Kepler has widely exceeded all our expectations and paved the way for our exploration and search for life in the solar system and beyond. These are the words of Thomas Zurbuchen, the Associate Administrator of NASA's Science Mission Directorate in Washington, marking the occasion of Kepler's official retirement from active duty. In the wake of Kepler's performance, it can now be confirmed that there are more planets in the Milky Way galaxy than stars. This means our solar system is one of only many in our cosmic neighborhood. Surveying the Cygnus constellation. When Kepler was launched into orbit, its measuring devices were programmed to focus on a section of the sky in the constellation Cygnus, which is located on the plane of the Milky Way. For the first 3 years of its existence, the Kepler Space Telescope collected data while observing approximately 150,000 main sequence, active and still in the prime of their lives, stars located in that area. The Kepler was searching for small dips in brightness of the light emitted from these stars, which could occur whenever a planet in orbit passed across a star's face. The size, composition, and orbital distance of these planets could be inferred from these observations. This is a reliable method for discovering exoplanets, planets outside of our solar system, and the Kepler performed its mission ably for 3 years. Unfortunately, in the summer of 2012, it experienced significant mechanical failures, as 2 of the wheels in its orientation system failed. This made precise control of Kepler's instrumentation impossible, which for a while put the entire mission at risk. All activity of the Kepler was halted as NASA scientists mulled over their options. Eventually, they did find a solution that kept the Kepler in commission, and at that point, its original mission was officially terminated. While the end for Kepler's initial mission came more quickly than expected, its quest still proved highly fruitful. According to figures released by NASA in 2017, the final tally for Kepler's survey of the sky in the Cygnus constellation was 4,034 planetary candidates discovered, including 50 with Earth-like characteristics orbiting in habitable zones, and 2,335 new planets confirmed, including 30 of the 50 Earth-like candidates. These numbers meant that between 1 to 2% of the planets found resembled Earth in size, composition, and location. This may not sound overly impressive, but it must be remembered that we live in a Milky Way galaxy that contains somewhere between 100 billion and 400 billion stars, with a population of planets that far exceeds these totals. If only 1% of the existing planets was Earth-like, it would mean billions of Earths were orbiting stars in our very own galaxy, which is only one of 100 billion galaxies believed to exist in the known universe. K2, a new directive. When Kepler lost its ability to orient continuously towards Cygnus, its assignment was changed. Instead of looking in one direction, it was allowed to change its focus as it moved around the Sun. New regions of the sky were scanned every few months, in a search for relatively brighter and closer stars and planets. The initial Kepler mission had been looking primarily for dim stars and distant planets, but during K2, the telescope was repurposed to help NASA fill in the gaps and contain a more complete picture of what might be out there. From 2015 through 2018, the Kepler Space Telescope continued to perform its duties admirably. By the time its mission ended, the final count for the two Kepler missions combined was over 5,500 exoplanet candidates, either verified or likely to be verified in the future. In its planetary catalogue, the Kepler Space Telescope found quite a few gas giants, like Jupiter or Saturn, in our solar system, which are made primarily of hydrogen and helium and are sometimes referred to as failed stars. It also uncovered many ice giants, like Uranus and Neptune, which contain heavier elements like oxygen, carbon, and nitrogen in frozen or liquid form. However, the most common type of planet found belong to a category unfamiliar to our solar system. These are planets with rocky cores that mostly fall into a size range somewhere between the Earth and Neptune, roughly between 15,000 and 45,000 kilometers in diameter. Interestingly, the vast majority of these planets are somewhat larger than Earth or somewhat smaller than Neptune, with not much representation between these two subcategories. For reasons that currently baffle planetary scientists, it appears the Neptune-like planets were originally in the Earth-size range but swelled up like balloons after absorbing small amounts of hydrogen and helium. The endless search for life as we know it and don't know it. The total number of Earth-like planets found in habitable zones by Kepler was not that high. The final number will likely be somewhere in the low hundreds, but they are common enough to suggest that we are far from unique. Based on statistical projections, planetary scientists examine the Kepler data estimate that between 20 and 50% of the stars in our galaxy have small, rocky planets in the Earth-size range revolving in their habitable zones. Essentially, this means these planets would experience temperatures moderate enough to allow liquid water to flow across their surfaces, which would likely encourage the evolution of life. While NASA's focus on finding Earth-like planets in so-called habitable zones is understandable, other worlds might also be capable of supporting life. Some scientists theorize that moons or planets orbiting stars outside the habitable zone could function as crucibles for evolutionary processes if they have oceans or lakes either underground or beneath icy surfaces. Mars and Jupiter's moon Europa are two bodies in our solar system that fit this description, and according to experts, both may be inhabited by microbial life or by something even larger. William Barucki, the space scientist from NASA's Ames Research Center, who was listed as the principal investigator on the Kepler project, acknowledged the importance of finding planets with similar characteristics and histories as Earth. But he also noted that Kepler had discovered planets completely unlike those in our solar system. Some of those, in fact, might be actual water worlds. We've also found planets that were formed at the beginning of the formation of our galaxy 6.5 billion years before the formation of our own star and before the formation of the Earth. Imagine what life might be like on such planets. Imagine, indeed. In April 2018, NASA launched its latest space program, the Transiting Exoplanet Survey Satellite, TESS. This next-generation instrument will scan an area of the sky 400 times bigger than the area covered by Kepler, and it's projected to find as many as 20,000 new exoplanets. With such a massive collection of data, surprises are bound to be uncovered. The way we think about the universe and about the possibilities of life elsewhere will likely continue to evolve. A new report published in the latest edition of the American Journal of Modern Physics has revealed a startling finding. A newly developed telescope with concave lenses has observed for the first time entities in our terrestrial environment that are invisible to our eyes and to conventional Galileo telescopes with convex lenses. Even more surprising is the fact that these entities have been observed to move intelligently in the night sky in a manner suggesting unauthorized surveillance of the area. revolutionary new Santilli telescope. The discovery was made by Dr. Ruggero Santilli, a highly regarded expert in mathematics, cosmology and physics, who has been nominated for Nobel Prizes in physics and chemistry. Dr. Santilli developed a new type of telescope that was designed to observe antimatter light. This form of light has a negative index of refraction, thus requiring concave lenses to focus it, rather than the traditional convex lenses used in conventional Galileo telescopes. Using a pair of Galileo and Santilli telescopes, Dr. Santilli found the first-known evidence of the apparent existence in our universe of antimatter galaxies, antimatter asteroids, and antimatter cosmic rays. These results were published in the journal Clifford Algebras and their applications in 2014. But that is not all the new telescope observed. Detection of invisible terrestrial entities. In his paper, Apparent Detection via New Telescopes with Concave Lenses of Otherwise Invisible Terrestrial Entities, ITE, Dr. Santilli relates the moment his new telescope found a lot more than he anticipated. On September 5, 2015 at 9:30 p.m., the author aimed a pair of 100mm Galileo and Santilli telescopes at the night sky over Tampa Bay in Florida, as seen from the northeast orientation of the terrace of room 775 of the Vinoy Renaissance Hotel in St. Petersburg. The tests were merely intended for the search of antimatter galaxies and, consequently, the paired telescopes were aimed at the sky. But sudden clouds halted the tests, and the author orientated the pair of telescopes horizontally over Tampa Bay. To his great surprise, unidentified yet clearly visible entities immediately appeared in the screen of the camera attached to the Santilli telescope, without any enlargement, without the same entities being visible to the naked eye, and without any corresponding image existing in the screen of the camera attached to the Galileo telescope. This unexpected discovery triggered a novel, systematic use of the pair of Galileo and Santilli telescopes, this time for the search of entities, here called invisible terrestrial entities, that are invisible to our eyes as well as to our optical instruments with convex lenses, but are otherwise fully visible via the Santilli telescope with concave lenses and are located in our terrestrial environment. Invisible terrestrial entities of the first kind, ITE-1. Following his first observation, Dr. Santilli carried out systematic tests and observations and came to identify two different types of invisible terrestrial entities, ITEs, though he acknowledges that further types may be identified in the future. Both types have been independently verified by colleagues, and their existence was discovered for the first time at an invited lecture delivered at the St. Petersburg Astronomy Club on September 25, 2015. He identifies the first kind, ITE-1, as entities that 1. Are not visible to the human eye or to conventional optical instruments with convex lenses, but are otherwise fully visible via Santilli telescopes with concave lenses. 2. Exist in our terrestrial environment rather than in deep astrophysical spaces. And 3. Leave dark images in the background of digital cameras attached to Santilli telescopes. Dr. Santilli notes that the entities move slowly and rotated. This particular type of motion excludes impurities in the telescope lens or in the camera as possible interpretations. He further notes that the emission of antimatter light does not mean that the entity is made up of antimatter, because the existence of the entities within our atmosphere would imply a cataclysmic explosion due to matter-antimatter annihilation. In short, writes Dr. Santilli, it appears that ITE-1 consists of matter entities in our terrestrial environment achieving locomotion via the acquisition of antimatter in their interior with consequential use of matter-antimatter propulsion, and achieve invisibility via the emission of antimatter light as a sort of exhaust. Invisible terrestrial entities of the second kind, ITE-2. He defines the second kind, ITE-2, as entities that are not visible to the human eye or to conventional optical instruments with convex lenses, but are otherwise fully visible via Santilli telescopes with concave lenses. 2. Exist in our terrestrial environment rather than in deep astrophysical spaces. And 3. leave bright images in the background of digital cameras attached to the Santilli telescopes. Unlike the ITE-1s, which leave dark images caused by a light of equivalent to antimatter light, ITE-2s appear to be composed of matter that leave bright images caused by ordinary light, which possess invisibility due to the conversion of their index of refraction from a positive to a negative value. Dr. Santilli notes that the ITE-2s were pulsating and moving systematically backward and forward, and suggesting they were conducting unauthorized surveillance of the Tampa area, solely visible with the Santilli telescope, thus confirming the need for systematic views of sensitive civilian, industrial and military installations. In his report published in the American Journal of Modern Physics, Dr. Santilli explains the significance and potential applications of this revolutionary discovery. The writing of this paper has been motivated by the fact that ITE-1 and ITE-2 behave in a manner strongly suggesting the conduction of unauthorized surveillance of our sensitive, civilian, industrial and military installations, thus warranting the societal knowledge. On scientific grounds, the documentation presented in this paper establishes beyond credible doubt the existence of two new types of light that are totally outside any possibility of treatment via 20th century physical knowledge. On industrial grounds, the findings presented in this paper establish, also beyond credible doubt, the utility of Santilli telescopes, not only for basically novel astrophysical advances, but also for issues pertaining to personal, industrial, and national security. The world's largest radio telescope is expected to come online sometime in 2020. The Square Kilometre Array, SKA, is an internationally sponsored and funded initiative that will include more than 1 million square meters of collecting area when all of its installations are complete. With thousands of individual dishes and approximately 1 million low-frequency antennas at their disposal, astronomers will be able to survey the sky above the Earth in exquisite and comprehensive detail. Despite being based on our planet's surface, SKA image resolution quality will actually exceed that of the Hubble Space Telescope. One unique aspect of the project is that it will incorporate dishes on 2 separate continents in the Southern Hemisphere. SKA facilities in secluded desert regions of South Africa and Australia will work in coordination to supply scientists with a far more panoramic view of the sky than was previously attainable. Sky scanning speed will exceed previous standards by an impressive factor of 10,000, and the array's sensitivity will be 50 times greater than what radio telescopes have achieved before. The Karoo Array Telescope and the beginning of a new era. In South Africa, the precursor to the SKA project was a radio telescope called the Karoo Array Telescope, named in honor of the desert region where it sits. Before being absorbed into the larger Meerkat project, which represents the bulk of South Africa's contribution to the SKA system, the CAT-7 offered a preview of coming attractions and helped contribute to the advancement of radio astronomy in its own right. In 2013, just a year after it went into operation, the Karoo Array Telescope produced its first notable results. In an announcement published in the monthly notices of the Royal Astronomical Society, a team of international scientists, including astronomers from the University of Southampton, revealed their discovery of massive ejections of stellar matter from a binary star system located 30,000 light-years from Earth. What was observed was a neutron star system called Quirkinus X1. This is a 2-star system in which both stars orbit each other in an elliptical formation. One of these is a highly densely compact neutron star, which is a remnant of a much larger star that exploded and then collapsed in on itself. The star would likely be no more than 20 kilometers in diameter, making it appear as an insignificant dot next to its much larger companion. But with neutron stars, looks are deceiving. Their gravitational pull is that of a much larger object, and when the 2 stars in Quirkinus X1 come close, the super-dense neutron star rips out humongous clouds of material from its partner. This creates massive jet-like flares of stellar material that are highly energized and only identifiable on Earth from the radio waves they produce. The dramatic radio flares happen when the matter Circinus X1 has violently ejected slows down as it smashes into the surrounding medium, explained Dr. Richard Armstrong, an SKA expert from the University of Cape Town. These types of observations are crucial for understanding the processes of both accretion of matter onto extremely dense systems, such as neutron stars and black holes are both about the Sun's mass, and the so-called supermassive variety we now know to be at the center of most galaxies. Such events were not easy to discover before, but the brand-new composite antenna structure of the CAT-7 opened new opportunities for astronomers to explore remarkable and important phenomena occurring at incredible distances. It provides a unique glimpse of the laws of physics operating in extraordinary regimes, said astronomy professor Rob Fender from the University of Southampton in reference to both the CAT-7 telescope and the greater Meerkat project into which it has now been absorbed. Nearly all such events are associated with transient radio emission. By studying bursts from these phenomena, we can pinpoint the sources of explosive events. Meerkat opens for business. The CAT-7 was the centerpiece of the South African SKA project until June 2018, when the crown jewel Meerkat radio telescope was declared ready and fit for duty. This 64-dish, 8-kilometer installation, which is located near the town of Carnarvon in the desolate Karoo region, was introduced to scientists, government officials and the public at large during a special inauguration ceremony. Meerkat will address some of the key science questions in modern astrophysics. How did galaxies form? How are they evolving? And how did we come to be here? Proclaimed Fernando Camilo from the South African Radio Astronomy Observatory. For those purposes, Meerkat is the best in the world. It didn't take long for the Meerkat to produce results backing that statement. Even before it was officially brought online, it was already collecting data, and at the inaugural event, attendees were treated to spectacular images taken of the center of our galaxy, 25,000 light-years away, where a massive black hole holds the rest of the Milky Way in its iron grip. We didn't expect to use our telescope so early in the game, said Camila, but to turn it to the center of the galaxy and obtain these stunning images, the best in the world, tells you you've done something right. Just 1 year later, on July the 22nd, 2019, the Meerkat struck again. It solved a mystery that had puzzled astrophysicists for quite some time when it revealed the presence of colossal clouds of hydrogen gas in a mega-galaxy known as NGC 1316. This sprawling galaxy is located 60 million light-years away and was created by the collision of two smaller galaxies plus the absorption of several nearby satellite galaxies. This scenario of collision and merger has been identified as a key producer of galaxies throughout the universe, but the presence of hydrogen was never detected in NGC 1316 before, putting the story of its origin scientists had concocted in doubt. But when the Meerkat was trained on NGC 1316, it quickly found the elusive hydrogen clouds. Through the intervention of tidal forces, they'd been stretched thin and pulled into elongated tails, where they were obscured by the blinding visual field created by star clusters that had been shaped by the same forces. Just like that, a quandary that had confused astronomers was solved and a popular theory of galaxy formation was confirmed, all thanks to Meerkat. The amount of gas found is consistent with the expected based on merger theory, explained Paolo Serra, an Italian astronomer involved in the data analysis. Thus, thanks to these observations, all pieces of the puzzle are now in place, and we finally have a more precise and coherent understanding of the formation of this famous galaxy. Fernando Camilo echoed this praise of the Meerkat's advanced capabilities. This provides a wonderful taste of what Meerkat will do in the years to come, he said. Results like these show that Meerkat has begun addressing some of the key open questions in modern astrophysics, and we look forward to researchers in South Africa and from around the world joining us on a journey of scientific discovery. South African radio astronomy on the march. Once the entire square-kilometre array becomes operational next year, Astronomical researchers everywhere will have access to an extraordinary and expansive database of information. The SKA project will revolutionize the practice of radio astronomy and dramatically increase our depth of knowledge about how stellar and galactic evolution unfold. In coordination with their partners in Australia, the South African Radio Astronomy Observatory will have an opportunity to make history. Their involvement with the SKA project will elevate their international profile and make their country one of the planet's major hubs for 21st century ground-based exploration.